Lesson 2. Today we are evaluating expressions and combining like terms. But before we do that, we need to go over the order of operations. One way to remember it is the word PEMDAS. P-E-M-D-A-S. P stands for parentheses. Parentheses, as you know, can be those types of brackets, but we also have other sorts of brackets. We have kind of these box brackets, we have fancy brackets, or we can have something as simple as a fraction bar. A fraction bar could be used as parentheses because we could have things on top first that we have to deal with, and then things on the bottom that we have to deal with. As you know, we got to deal with 2 plus 3 first, and then on the bottom, x plus 2x. So that could be used as a set of parentheses. Our E are any type of exponents. All right, and those can be positive, negative, it doesn't matter, but as you know, an exponent is any number that is up here in the power spot. So, x squared. We would have to deal with that first before we move on then, if we can simplify it at all. For the next two, they kind of work together. Multiplication and division. Multiply and divide. Okay. These work together. You are going to use these as you see them from left to right. But they do work together, so whatever you see first, going from left to right, you deal with. And then, after that, then we do our last two letters here too. They are adding and subtracting. They also work together. As you know, these are inverses of each other, so they do kind of work together. These are also from left to right. And whatever you see first from left to right, you deal with. Alright, so to deal with some examples here. It says evaluate. Whenever we see the word evaluate, that means solve. And so then, when we solve it, we are getting an answer for this. Evaluate each expression if x equals -3 and y equals -1. We simply just put those in right away first. So we've got 3 times -3 squared. Notice I put that -3 in parentheses because a common mistake is taking the 3 squared and then just putting the negative on it. So it'd be a -9. That is wrong. Instead, what we have to do is we have to take the -3 squared, which is 9 times 3, minus -1 squared is 1. Notice I took care of the parentheses, and then I dealt with the exponents at the same time. Alright, so then what we do from there, our next step, since we don't have parentheses anymore, we don't have exponents, we deal with multiplication next. So 3 times 9 is 27, and then we deal with the -1 to get an answer of 26. For our next one, we need to first put our numbers in. So a -3 times -1 plus -3 squared times -1 squared. Alright, parentheses are just keeping our negative numbers inside there, so we can ignore that for now. But we do have to deal with these exponents over here. So a -3 squared is 9 times -1 squared is 1. I'm going to bring this other stuff down for now. Alright, now our next step that we have parentheses gone and exponents gone is to multiply these. -1 times -3 times -1. We've got 3 negatives, so that means our answer is going to be negative. 1 times 3 is 3, times 1 is 3, so that would equal a negative 3 plus 9 equals 6. We dealt with the multiplication and multiplication first, and then we added those together to get our 6. For our next one, it's the same concept, we're just putting numbers in here. So 5 times negative 3 squared minus 5 minus negative 3. Notice that these last two numbers have to be in parentheses there. We've got to deal with those first. So 5 minus negative 3, 5 plus 3 is 8 minus, then we can deal with our exponent here. Negative 3 squared is 9 times 5, so 45 minus 8 is 37. Our next one, put the numbers in again. 5 squared times negative 3. And notice, once again, those parentheses are there to make sure the negative goes with the 3 there. Plus 3 over negative 2. Now remember, I said earlier, this division bar acts like a set of parentheses. You gotta deal with the top first. So we need to square our 5 to get 25 times negative 3 plus 3, and that's all over 2, negative 75 plus 3 over 2, negative 75 plus 3 is negative 72 over 2, which equals negative 36. When you put everything in there right, and you do our order of operations correctly. Next one, we can also do the same concept, but just by simplifying the expression. Alright, so we're going to look at this. We're going to add like terms here. Well, one of the first things that we see is we see this 8 and this negative 3 can combine down to a 5. We also see that we don't have any other m terms here, so that would be a negative 2m plus 5 for sure. Now this and this, those look pretty similar. Remember, we can do the commutative property where we can make these look the same. This first one, I could rewrite as 7pm. Now because of that, now we see that we have like terms here, so we can add those. So we've got 12pm minus 2m plus 5. That would be as simplified as we can get. We don't have any other like terms there, so that would be our final answer. For our next one down below, if you look here, we don't have a whole lot of like terms. We have a negative 2x squared and another negative 2x squared, so we could add those together to get a negative 4x squared, and I'm just going to bring the rest of these down. From here, we're not completely done. Some books say that you're done, but we do need to reorder these a little bit. We will talk about degrees later on, but if two terms have the same degrees, what do you do with them? Degree is just the exponents that go along with it. We should order these in the right order from highest degree to lowest degree, and then because these two degrees are the same, then we do it in alphabetical order. So our negative 4x squared would come first, then our 7y squared comes next. If you look at these two, they both have a degree of 1. Well, which one comes first? Again, it is alphabetical order, so the x comes before the y. This would be the most correct answer. A lot of people, though, say that this first one would also be correct. To me, it doesn't matter. I just want to make sure that when you get to college, there'll be a lot of professors that expect you to do it and put it into this bottom format. Alright, word problem for this. Okay, as you can read it here, it says list the areas of the smallest three sheets of metal. Alright, so which ones are they? We've got to find the areas for each one of them. They're all rectangles, so we know that the area of a rectangle is base times height. So if we look at this first one, we've got 4 and an x, we multiply those together to get 4x. For our next one, 3 times 2x is 6x. 4 times 0.5x would be 4 times 0.5 is 2, and then bring the x with. 3 times 5x is 15x. Now what it says is to list the areas of the smallest 3 sheets of metal. Well, that would be 2x, 4x, and 6x. And then it says, what is the sum of these 3 sheets? Well, we're going to add those together. They're all like terms. So 2 plus 4 is 6, plus 6 is 12x. And then for area, we've always got to have some kind of unit on there. We don't have a unit in this problem, so this would be units squared. And that is it. Make sure you follow order of operations to do these problems.